If you look at the physical foundation of modern artificial intelligence, most roads lead back to one company's hardware. NVIDIA GPUs are currently the foundational layer of the entire AI industry, but the primary workload is changing. We are moving past the experimental phase of training models and into the mass market phase of inference, actually running those models for millions of people in real time. This shift has triggered a massive disruption from one of the industry's leading labs. Anthropic, the developer of the Claude models, is intentionally bypassing NVIDIA's standard GPU hardware. To do it, they formed a new alliance with Google Cloud and Broadcom to scale their own custom silicon. The scale of this move is extraordinary. It is a $21 billion commitment for up to 1 million custom chips and 3.5 gigawatts of power. It represents a direct structural challenge to the current hardware monopoly. This pivot is documented in Broadcom's SEC filings and Google's recent public disclosures. This isn't industry rumor, it is a massive capital allocation. According to the deal terms, Anthropic will begin accessing this massive capacity between 2026 and 2027. NVIDIA GPUs are the proven gold standard, so why are the world's leading engineers betting tens of billions of dollars on Google's custom architecture instead? Breaking a hardware monopoly requires solving three distinct problems: inference-specific hardware, system-level networking, and software integration. The first pillar is Google's 7th-generation TPU, known as Ironwood. It is an ASIC, an application-specific integrated circuit. Unlike a general-purpose GPU, it was built exclusively for AI workloads, prioritizing throughput and energy efficiency. But high-speed chips create a networking bottleneck. Traditional data centers rely on electrical routing, which requires constant electro-optical conversions that drain energy and increase latency. Google and Broadcom bypass this by routing light directly. Using optical circuit switching, or OCS, they reflect optical signals with physical mirrors, cutting both power consumption and communication delays. With single-chip thermal outputs exceeding 1,000 watts, air cooling is no longer viable. This architecture requires integrated liquid cooling to keep the system stable. Ironwood and OCS change how engineers think about AI infrastructure. They are no longer optimizing individual chips, but tightly integrated blocks of entire server racks. The third pillar is software. Even the fastest hardware array is useless if developers can't easily program it. This is NVIDIA's primary advantage. Their CUDA software has been built over a decade and is used by millions of developers. Historically, replacing GPUs required a complete re-engineering of the software stack. For most companies, that cost was simply too high to justify. Google is attempting to dismantle this barrier with a project called Torch TPU. It is designed to make Google TPUs run natively on PyTorch, the open-source framework used by the vast majority of AI developers. If Torch TPU succeeds, it removes the primary hurdle for switching hardware. Custom silicon can finally compete based on its own price and performance. Anthropic is not an isolated case. Major cloud providers worldwide are shifting their capital toward developing their own in-house ASICs. These servers are projected to grow from a niche product to 25% of the global market by 2026. The shift is driven by a physical reality. Single rack power density is climbing toward 100 kilowatts, forcing data centers into a multi-megawatt era. The limits of thermodynamics and energy mean that the strategy of simply plugging in more independent GPUs has reached its end. This marks a transition in the industry. Success in the AI race is no longer about the performance of a single chip, but about mastering system-level orchestration. That orchestration requires a specific blueprint: custom inference silicon, optical networking, liquid cooling, and open-source software integration. The multi-billion-dollar alliance between Anthropic, Broadcom, and Google is the primary test case for this new model of computing. NVIDIA still holds the industry crown today, but the first multi-gigawatt machine capable of challenging them has moved from the drawing board to the construction site, and the countdown to its deployment has officially begun.